These changes make internal combustion engines, coal, and even nuclear energy obsolete, as sodium-ion hybrid batteries surpass lithium batteries in availability and cost-effectiveness by more than 30%. Additionally, sodium-ion batteries boast a high energy density and can charge up to 80% in just 15 minutes, marking a breakthrough in fast-charging technology as CATL demonstrates charging speeds up to 100 times faster than other EV batteries. How is sodium-ion hybrid battery officially leading the battery industry? How has CATL's sodium-ion hybrid battery revolutionized the electric vehicle industry? Imagine a battery with this type of energy density at $40 per kilowatt hour could end internal combustion, making it unable to compete with coal and possibly even nuclear. It essentially ends fossil fuels and is about to be revealed by the world's largest battery company. While lithium-ion batteries have been the energy storage technology of choice for electric vehicles since the early 2000s, a change is coming. Sodium-ion battery technology is emerging as a new player. Have you heard of sodium-ion hybrid batteries? In a recent demonstration, a prototype of this sodium-ion hybrid battery reportedly charged in a few seconds, according to researchers. This could be a game-changer, especially in the electric vehicle market, where range anxiety has been a barrier to adoption. Currently, CATL's sodium batteries have energy densities close to blade batteries. And for a reason, as CATL's sodium batteries have the highest energy density of any sodium-ion batteries being produced. There are about 10 companies making 7 million batteries, including some companies you may not have heard of, while some of the larger companies are in China. However, CATL has the highest energy density of all sodium batteries. They are working on a solid-state sodium battery that charges super quickly. However, another significant advantage here is that at room temperature, these batteries can charge up to 80% in just 15 minutes, a very fast charging rate. This new sodium-ion battery, as we've discussed, technically is a hybrid because it contains some lithium. It offers significant advantages such as good performance in cold weather, a challenge that many LFP batteries may struggle with, and cost-effectiveness due to its use of sodium instead of primarily lithium. With a very high energy density of 200 watt-hours per kg, it's truly remarkable. We know that sodium-ion batteries are cheaper, more environmentally friendly, and safer. However, they have lower energy density and take longer to charge compared to lithium-ion batteries. Sodium, being a heavier raw material than lithium and operating at a lower voltage, reduces the energy density of the battery and consequently the range of the vehicle. So, what makes this new type of battery, sodium-ion, so special? The sodium-ion energy storage systems have garnered attention for their superior safety, low raw material costs, and environmentally friendly certifications compared to the widely used lithium-ion ones. However, this tech faces challenges that incumbent companies can only overcome by cutting costs through technical efficiency improvements, establishing supply chains, and achieving economies of scale. There are two types of sodium energy storage systems: sodium-ion batteries and sodium-ion capacitors. The former is hindered by poor rechargeability due to low power density while providing relatively high energy density. On the other hand, the latter has a higher power density but very low energy density. Therefore, combining the cathode of a capacitor and the anode of a battery in a hybrid sodium-ion energy storage system, SIHES, is an active research area, blending the best of both worlds. Currently, researchers at CATL have reported a strategy to achieve high energy density and fast-charging SIHES systems. They have two separate metal-organic frameworks to optimize hybrid batteries. Specifically, SIHES has demonstrated an energy density of 247 watt-hours a kg and a fast-charging power density of 34,748 watts a kg, surpassing conventional battery reactions by over 100 times. It has shown stable cycle performance with a Coulombic efficiency of about 100% over more than 5,000 charge-discharge cycles. This means that this type of battery can store more energy for its weight compared to current sodium-ion batteries, and charge up to 100 times faster than other EV batteries. The battery maintains performance and operational efficiency over many cycles, indicating it can be used repeatedly over a long period without significant degradation. This approach has led to the development of anode materials with improved kinetics by incorporating fine active materials into porous carbon derived from metal organic frameworks. Additionally, a high-capacity cathode material has been synthesized, and the combination of cathode and anode materials enables the development of the SAHI systems, optimizing balance and minimizing energy storage rate differences between the electrodes. When considering factors in reducing carbon emissions, developing a more durable, efficient, and sustainable EV battery is key if we aim to permanently decarbonize our transportation sector. Currently, the production of electric vehicle batteries still has a negative impact on climate, but engineers are introducing new materials that are less harmful. First, nickel is poised to replace the expensive materials. U.S. researchers are exploring the use of nickel as both the negative and positive electrodes in batteries. Nickel mining emits far less greenhouse gases compared to cobalt, which is currently the most common metal in EV battery cathodes. Secondly, sodium could become a climate hero. Ions move from the cathode to the anode of batteries, generating electric current. Chinese battery giant CATL has developed a battery based on sodium ions instead of lithium ions, which are harder to mine. Third, nanomaterials could replace lead. Ions are bound in the anode and cathode of batteries. Researchers are aiming to create cathodes from nanomaterials, including iron, copper, and iron oxide rather than lead. This could provide 3 times the capacity and 5 times the battery life. How much does this hybrid battery cost? The cost of these hybrid batteries is currently one of the lowest on the market for the LFP battery from CATL and BYD. Just 2 years ago, CATL said their sodium-ion battery would be cheaper than their lithium-ion phosphate battery by about 30%. With the current price of LFP batteries ranging from $55 to $60 a kilowatt hour, imagine if these new types of batteries were 30% less. This could realize predictions that by 2030, there will be electric vehicles priced at around $5,000 with a range of over 200 miles. Do you believe this will happen? Currently, the largest cost of an EV is the battery pack, accounting for about 30% of the total production cost of the vehicle. However, battery prices have dropped by about half over the last 12 months, and if they continue to decrease due to these new types of batteries, that's going to be a major breakthrough. CATL stated that a 30% cost reduction, but this does not account for the fact that the battery pack could be made smaller due to increased energy density. This means the actual cost could go down even further. If energy density goes up by more than 30%, battery prices could halve. We're approaching the point where producing an electric vehicle is cheaper than an internal combustion engine. Battery prices have decreased significantly and will continue to decrease with these innovations. CATL, the world's biggest battery company, has just unveiled a truly groundbreaking product. This new battery has a lifespan equivalent to LFP, significantly higher energy density, lower cost, and performs a lot better in cold weather. This raises the question of how other companies can compete. Imagine if McDonald's had the best tasting and cheapest cheeseburger and 95% of their consumers agreed it was the best. That right now is CATL's position in the battery market. If you can invest in CATL, we strongly recommend you do so. The Chinese government has confirmed CATL's market dominance. Electric vehicle prices will continue to drop, and owning an EV will become a fantastic experience. It has to be acknowledged that CATL's made big strides in developing high-performance sodium-ion batteries. The latest generation boasts energy densities ranging from 160 to over 240 watt-hours a kg, comparable to early generation lithium-ion batteries. CATL aims to further enhance their performance, targeting up to 300 watt-hours, approaching mainstream lithium-ion battery levels today. CATL plans to mass-produce sodium-ion batteries starting in September. This move expands CATL's presence in the sodium-ion battery market with a production capacity of 40 gigawatt-hours a year. Sodium-ion batteries initially store 160 watt-hours a kg, less than 10% lower than the LFP batteries and less than 40% lower than nickel batteries. Achieving the 300 watt-hour target for the next generation of sodium-ion batteries reflects CATL's commitment to innovation and sustainability in energy storage, demonstrating the company's competitive position in the rapidly growing battery market. So, how are other companies responding to the development of sodium-ion hybrid batteries? The Swedish battery company Northvolt recently collaborated with leading Chinese electric vehicle manufacturer BYD, stating their progress in addressing multiple application challenges. Unless we miss something, U.S. automakers have yet to achieve their targets. Instead, their focus remains on stationary energy storage. Natron Energy in California recently launched the first factory in the States with a focus on energy storage systems for load balancing and addressing power outages at data centers. Ohio-based Aculine Energy is another U.S. energy storage company exploring opportunities in sodium-ion technology. Sodium-ion batteries in general are advancing rapidly. Last week, Natron Energy Incorporated announced plans to build their first large-scale sodium-ion battery factory in the U.S., slated to be near the west coast of Michigan. Bloomberg NEF predicts that sodium-ion batteries will capture 12% of the stationary energy storage market by 2030. In Japan, researchers at Osaka Metropolitan University have developed a new method for producing solid-state sodium-ion batteries. The research team created a solid sulfide electrolyte with the highest reported sodium-ion conductivity in the world. That's about 10 times more than practical application requirements. Okay, so what benefits will the application of CATL's sodium-ion battery technology bring to Tesla's new vehicle models? Applying CATL's sodium-ion battery technology could bring significant changes to Tesla's new vehicle models, including the Model 2 and Tesla van. This technology offers fast charging capabilities, a crucial factor in eliminating range anxiety and significantly boosting electric vehicle EV adoption. Faster charging times enhance user experience, making EVs more convenient and appealing, thereby aiding the transition from fossil fuel vehicles to electric ones. Tesla could invest in research and development to further understand the potential of sodium-ion batteries, conducting lab tests and collaborating with battery companies like CATL. Redesigning battery structures and management systems, BMS, to be compatible with sodium-ion characteristics could be the next step. Successful implementation could establish a robust supply chain, partnering with battery suppliers and building manufacturing facilities to ensure stable supply and cost reduction. Sodium-ion batteries are cheaper to manufacture, potentially reducing costs by up to 30% compared to current lithium-ion batteries, which currently cost around $100 to $120 a kilowatt-hour. If sodium-ion battery costs go down further by 30%, they could range from $70 to $84 a kilowatt-hour. This presents a significant advantage for the Model 2, expected to be an affordable mass-market EV. Using sodium-ion batteries could help the Model 2 achieve competitive pricing while maintaining high performance and fast charging capabilities, enhancing its appeal in the market. For Tesla's van, sodium-ion technology also offers numerous benefits. With high energy density and fast charging capabilities, sodium-ion batteries can extend the operational range and shorten charging times, meeting user needs in commercial applications and freight transportation. Sodium-ion batteries can achieve energy densities of up to 200 watt-hours a kilogram, higher than the current lithium iron phosphate batteries with approximately 160 watt-hours. This means Tesla van could have longer operating ranges with lighter battery weights, improving overall efficiency. Promoting the fast charging capability and sustainability of sodium-ion batteries could attract customers, especially those concerned about the environment. Sodium-ion batteries use sodium, a more abundant element compared to lithium, reducing environmental impact and dependence on scarce resources, enhancing the sustainability of these vehicle models. CATL's sodium-ion battery technology has the potential to enhance performance, reduce costs, and strengthen sustainability for Tesla's new vehicle models, like the Model 2 and Tesla van. With battery costs potentially decreasing to $70 to $84 a kilowatt-hour, energy densities are reaching 200 watt-hours, and fast charging capabilities hitting 80% in just 15 minutes, these factors are going to be crucial for Tesla's future development and competitive strategy. How is Volkswagen contributing to the development of sodium-ion hybrid batteries? PowerCo, a subsidiary of the Volkswagen Group, has recently announced a groundbreaking agreement with QuantumScape to industrialize QuantumScape's next-gen solid-state lithium metal battery technology. Upon achieving significant technical milestones and certain royalty payments, QuantumScape will grant PowerCo a license to mass-produce cell batteries based on its tech platform. Through its non-exclusive licensing agreement, PowerCo aims to produce up to 40 gigawatt-hours of batteries a year, with an option to expand to 80 gigawatt-hours, enough for 1 million electric vehicles a year. QuantumScape's solid-state technology utilizes ceramic separators to enable a high-energy, pure lithium metal anode with higher energy density and power output, along with faster charging rates. Similar to other solid-state battery technologies, QuantumScape has long demonstrated the viability of this concept in laboratory and smaller-scale environments. But scaling up production for use in vehicles over multiple years presents a challenge. In addressing this challenge, the companies have stated that they'll combine core capabilities with a collaborative workforce initiative to accelerate the scale-up process and integrate these components into Volkswagen's vehicles. Details regarding the potential future location of solid-state battery production and timelines has not yet been disclosed. Volkswagen commenced construction of its first EV gigafactory in July of 2022, coinciding with the formal establishment of its PowerCo business unit overseeing the facility. Located in Salzgitter, Germany, this site serves as Volkswagen's global hub for battery operations and marks the beginning of what VW calls a global battery attack, centered around localized battery production and vertically integrated supply chains aimed at cutting battery costs by half. At Volkswagen's Power Day 2021 event, a solid-state battery technology was hailed as the ultimate game in the transition to electric vehicles, with expectations for small-scale introduction around 2025 or later. VW sees solid-state technology enabling 80% charge in just 12 minutes. VW views solid-state batteries in QuantumScape as part of its long-term strategy over a decade or more. The collaboration with QuantumScape dates back to 2012. Toyota is developing solid-state batteries with Panasonic and anticipates commercial readiness around 2027 or 2028. Honda sees them as enabling tools for affordable small electric vehicle production, while Nissan is pursuing its own solid-state battery development and sees potential advantages in the packaging of electric vehicles that could change the game. What's the significance of hybrid sodium-ion batteries for the electric vehicle industry? The adoption of sodium-ion hybrid battery technology could bring significant changes to the EV industry and has the potential to reshape how we approach and use transportation. One of its key advantages lies in fast charging times, heralding a new era for electric vehicles. Faster charging eliminates a long-standing concern about range anxiety, making EVs more convenient and appealing to consumers. Rapid charging not only enhances user experience, but also significantly boosts EV adoption. Currently, one of the major barriers to transitioning from fossil fuel-powered vehicles to electric ones is those lengthy charging times. With sodium-ion batteries, electric vehicles can charge up to 80% in just a quarter of an hour or 15 minutes. That minimizes wait times and enhances our flexibility as users. This capability has the potential to drive a robust shift towards electric vehicles, cutting emissions and environmental pollution. Beyond automotive applications, sodium-ion battery technology promises to improve the efficiency of smart electronic systems and renewable energy storage. In energy storage systems, sodium-ion batteries can provide efficient and sustainable storage solutions. This is crucial for the widespread deployment of renewable energy sources like solar and wind, which require reliable energy storage systems to operate effectively. Recent advancements in sodium-ion battery technology are evident, such as Natron Energy Incorporated's plan to build the first large-scale sodium-ion battery production facility in the U.S. This marks a significant step towards commercializing sodium-ion battery technology and opens up possibilities for mass production, thereby reducing costs and improving accessibility. Not limited to the U.S., researchers in Japan have also made strides in solid-state sodium-ion battery technology, achieving unprecedented sodium-ion conductivity. This innovation not only enhances battery performance, but also opens up new applications across multiple sectors, from consumer electronics to industrial energy storage systems. These developments signify a promising future for sodium-ion battery technology. With its fast charging capability, lower production costs, and high performance under harsh conditions, sodium-ion batteries could become the new standard for many different applications. In the electric vehicle industry, this technology not only improves range and reduces costs, but also enhances battery safety and durability. CATL's sodium-ion battery technology and advancements from components and research institutions worldwide are creating new opportunities for the electric vehicle industry and other energy applications. The fast charging capability, lower costs, higher energy, and sustainability of sodium-ion batteries not only provide economic benefits, but also play a crucial role in environmental protection and promoting sustainable development. With these potentials, sodium-ion batteries could become a critical factor in driving the development of electric vehicles and clean energy solutions in the future. We hope you'll experience the utmost relaxation after watching this video. If you do, please press the like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon and stay tuned for any fantastic videos. Your feedback and time are highly appreciated. Thanks for watching, and we look forward to seeing you soon. Until then, stay safe, take care, and God bless.